Welcome back everyone. Today we're going to be looking at step 3 on how to lose weight, and that is to substitute soft drinks for water. When we eat, we feel very satisfied, we feel a sense of reward, and the reason that throughout history, throughout evolution, we have developed these feelings is to stop us from starving. So it is a very important physiological mechanism. Now, different foods will cause a different reward feeling. So those highly palatable foods that have a lot of carbohydrates and a lot of fats tend to have a bigger reward. Now, there is a large correlation between the introduction of fructose heavy enriched foods into our society, such as soft drinks, and the increase in obesity. Usually fructose or sucrose is found in fruits. However, the difference is, fruits are actually quite healthy to eat. They have lots of fiber, nutrients and vitamins that we need for everyday living. However, in soft drinks, the fructose is at such high concentrations that our bodies are not able to deal with this effectively. And that is what the literature is suggesting that's coming out. Okay, so let's have a look at how our body reacts to soft drink. We'll start off like we started last time with the empty stomach. So in the empty stomach, you're going to have the release of ghrelin because there's no food in the stomach. Ghrelin, as we mentioned before, is going to stimulate hunger. It's also going to stimulate food-seeking behavior. Food-seeking behavior. And there was a study with some women that showed that in order for you to feel that reward feeling after eating, you need to have ghrelin present. So it's also involved in the reward. Okay, now let's drink some soft drink. So we have soft drink here. And you drink the soft drink and it travels to your stomach. Not much is going to happen in your stomach, and then it goes straight through to your small intestine. Now, the reason it just goes straight through is because it's a liquid. So not much digestion has to happen. It's in a sucrose, is a disaccharide that is made up of two sugars, glucose and fructose. When they get to the small intestines, there are enzymes found in the brush border here in the cells of the epithelium. And those enzymes, they're proteins that are going to break the bond between the two sugar molecules so that you have, so that you just have the monosaccharides, the single molecules. Okay, so fructose is then going to be absorbed into the circulation. And the other thing that we're going to get is that we're going to get glucose. Because remember that for each molecule of sucrose, you're getting one of fructose and one of glucose. So you're going to get glucose as well. 50% of the carbohydrate is going to be in the form of fructose and 50% in the form of glucose. Glucose, as we mentioned before, is going to go to the pancreas, or it's going to go all over your body, but some of the glucose is going to go to the pancreas and it's going to cause the release of insulin. Insulin, as we mentioned before, is then going to go and promote feelings of satiety and decreased appetite. Now today I'm not focusing on the different areas within the brain. So you have a reward area, you got a hunger center, a satiety center. There's lots of different areas within that are involved in this process, but I'm keeping it simple And sometimes the hormones will act on the same part of the brain. One will stimulate and the other one will inhibit. I'm just putting the final effect from these hormones. Insulin, as I mentioned before, is also going to affect your adipocytes or your fat cells, and it's going to cause an increase in leptin release. So you're going to get increased leptin, and this is going to add to this outcome so that you're full. So say if you have a meal, these hormones get released, eventually you will feel full and satisfied. Now, when you have fructose, the proportion of insulin and leptin that is released relative to the total carbohydrate load that you've consumed is less than if all this was glucose. So that not as much insulin and not as much leptin is released. So I'm going to illustrate that by having a decrease in insulin and decrease in leptin as a result of fructose. Now, if we have a decrease, if there's not as much of these hormones relative to the total carbohydrate that we've consumed, then basically our brain thinks that we haven't consumed as much as we did. And so what happens is you're not as full then, and you're also hungry. And the reason you're going to be hungry is because fructose doesn't inhibit ghrelin as well as glucose does. And the main reason I would suspect is that because we drank a drink, it's very fluid, it just goes straight through, so there's actually not going to be any food in your stomach. There's not going to be much there to inhibit ghrelin secretion. So ghrelin's going to be high after a soft drink, which is going to make you feel hungry and seek out food not long after you've drank the drink. And also to get that reward feeling. So fructose has been associated with getting more of that reward feeling as well. The other interesting thing about fructose is that there are studies showing that people that consume a diet high in fructose develop leptin resistance and insulin resistance. Now, what does that mean? Well, it means that in order to get the same effect in the brain, you got to have a lot more insulin and you got to have a lot more leptin. Now, for example, if you remember from last week, the amount of leptin that you release is directly proportional to the amount of fat that you have in your body. So in order for us to tell the brain that you're full, you're going to have more fat so that you can release more leptin. So you're going to potentially put on more weight until the level of leptin is able to be detected by the brain. And something similar with insulin. So I hope that this brings a little bit more clarity as to why it can be so detrimental to drink soft drinks, and especially for your weight. And I hope to see you next week.